Hi everybody. We wanted to share a quick learning sequence that we've been using to transition learners from counting through to being able to partition numbers and so on. And what we particularly wanted to have a look at is how to do that at the lower levels of the learning progressions to develop foundation level numeracy skills and also develop mathematical problem solving skills. So if you've got a few minutes, we thought we might just work through this. Okay, so we want to develop foundation level numeracy skills and high level mathematical problem solving skills for those adult learners who are operating more at the lower levels of the learning progression. We want to train them to be great problem solvers, but also we want the content to be at a level where they can be successful and engaging productively in that. So here's what we're going to have a look at. We're going to have a look at how to support learners to shift from counting through to partitioning. And if you want to know more about this, sign up to one of the Numeracy Toolbox courses. But number one activity we're going to look at is just covering part of a number and saying what is under the paper, what number is under the paper. This will make sense to you soon. Breaking up numbers using counters to find possible ways to partition a number. We're going to use a magic square activity and we're going to use a dice game activity. So here we go. You would sit down with the learner. You can do this one-on-one or you can do this in groups, small groups, and you explain to the learners that this exercise is to develop their foundation number skills. And even if it's easy, it's still going to sort of develop their brain's ability to see multiple ways to manipulate numbers. So what you do is you hand out counters to each learner. You can do this one-on-one again, or each group would get a series of counters, and this is how you start. There are 6 counters altogether. How many are under the piece of paper? And then you just let them work it out. And if they get it wrong, for example, if they go 3, 4, 5, 6, 7, and they think 4, you just show them that it's 3 and they'll work it out themselves. And so this is for learners who would be counting all of the objects to do it. And so you might say, hey, there are 8 counters altogether. How many are under the piece of paper? And you might find that they go 3, 4, 5, 6, 7, 8, and they count up on their fingers and keep a tally. And so what you want to do is show them that that's correct, but you want to progress them from counting on their fingers to counting in their head, and then finally just to making the leap. You can progress this again. There are 12 counters altogether. How many are under the piece of paper? I'll let you work that out very quickly. Okay, so maybe you went 1, 2, 3, 4, 5 dots there. That means another 5 will get us to 10 and another 2 to 12. So 5, 6, 7. That's really good. What we're also doing here is we're subitizing. So as you look at those dots, the idea is 1, 2, 3, 4, 5. You might be able to recognize that there are 5 counters there, I should say, before actually counting them all, just being able to see that there's 5. So you can see that this activity progresses the learner's ability to be able to segment up numbers, to partition numbers, to know that 12 can be divided between 7 and 5 or split into 7 and 5 and so on. Here we could just progress it more. There are 23 counters altogether. How many are under the piece of paper? Have a go at that. Okay, and maybe you were able to this time go 3 and 3 is 6, 7, 8. So you're able to count those counters quick. And then maybe 8, you just rounded that to 10. 10 and how many do we need to get to 23? 13. And so another 2 would be 13, 14, 15. So there are 15 there. And perhaps maybe you are already using more sophisticated strategies to do this. And so the idea is you can use this activity with learners who are transitioning from counting to partitioning up numbers. Now, I like to do this in very small doses, less than 10 minutes, and then move on to something else. So let's have a look at what the next thing could be. Well, here's a really interesting activity to do with the learners to help them partition up numbers. You hand out 5 counters and you say, how many ways can you break 5 into 2 different numbers? And so learners will be like, oh, okay. You do this with the counters, by the way. 1 and 4, 2 and 3, 3 and 2, 4 and 1. Okay, so they might go, oh, there are 4 different ways of doing it, but actually these 2 are doubles, so we're going to eliminate those. So there's actually only 2 ways to divide 5 up into 2 different groups of numbers, 1 and 4, 2 and 3. Somebody mentioned 0 and 5. You could do 0 and 5 if you wanted to introduce that. But sometimes I think maybe keep the zeros out of it for now. We're trying to break it up. So how many ways can you segment 5 into 2 parts? Well, there's actually only 2 ways. Now, you do this again with 8, and so the learners become the explorers. Gee, how many ways can you divide up into 8 into 2 parts? Well, 1 and 7, 2 and 6, and remember they might be just breaking it up with the counters at this point. 3 and 5, 4 and 4. There are 4 ways to break up 8 into 2 different parts. And so what they're learning here is they're becoming explorers and investigating numbers, and also they're becoming familiar with numbers like 8, that 8 is actually made up into 1 and 7 and 2 and 6 and so on, a bit like Russian dolls. They're all nested in. You know, there's all these other numbers and combinations that are nested within 8, which is what we want these learners to develop. Okay, if you want to advance it a little bit more and you've got people working well in groups or individually, you could try this. How many ways can you break up 6 into 3 parts? And so it's like, okay, well, we could have 1 and then 2 and then 3. So 6 can be broken up into 3 parts that way. And then you could go 2, 2 and 2, but that's it. That's actually it in terms of breaking 6 into 3 parts. And you might do a few of those and then leave it. And so the point is you're just working with low levels of counters. You're talking about it in groups, sharing ideas and becoming explorers of these numbers. Now, there's a point to this. Let me show you the next activity that you can move into. Well, this is called a magic square. And the magic square is really cool. It's got a whole lot of history around it that's quite interesting to introduce to the learners if they're so inclined. But basically the challenge is to write all the numbers from 1 to 9 into this magic square so that it equals 15 diagonally, vertically, and also horizontally. So it's got to equal 15 each way. Now, usually what will happen is learners will just sort of start guessing where to put the numbers. So they'll put 1 maybe, and then they'll put a 9 and a 5, and that equals 15. And then they might work down the side. 5 and 6 is 11, and 4 is 15, so they've got 15 there as well. And then they kind of look at this diagonal and they go, right, we've got 1 and 4, that's 5, so that means 10 would have to go in the middle, but we're not allowed to use a 10, so that's not going to work. And so they're going to have to then rearrange it, and you'll find they rearrange it and they become frustrated very quickly because it's quite tough. When they're becoming frustrated, it's a great way to introduce to them, hey, let's use our mathematical skills that we've been learning partitioning up numbers to try to solve how to do this problem. Or how to solve how to do this problem. So let's just think about the magic square for a moment. You have these different boxes that numbers have to be in to make 15. So if we just think about a corner that goes in the top left-hand corner, this number here, whatever it is, has to be involved in making 15 here, 15 across here, and 15 diagonally. So it has to be involved in 3 different ways to make 15. This number here, on the other hand, can you see how many ways that has to be involved with making 15? Well, it has to be involved with making 15, 1 here and 1 across here, but that's it. So 2. So if it's on the side, it only has to be involved in making 15 twice. What about the number that's in the middle? How many times does that have to be involved in making 15? Let's see. Well, it has to make 15 across here, up and down, diagonally this way, and diagonally this way. So that means it has to be involved in making 15 4 ways. So that's interesting. Top corner has to be able to make 15 3 ways, sides only 2, and middle 4. Now, remember when we were doing the counters and we were breaking the counters up into 3 parts, we could break 6 up into 1, 2, and 3, or 2, 2, and 2. Well, now we're going to do the same thing, but we're going to do it with 15. And we're going to think about, gee, how many ways can we actually break this up into 3 different numbers under 9 or 9 and under that still equal 15? And we're not allowed to double numbers. So, or we could have a 6 there. We could have a 4, and we could have a 5. That equals 15. So that's one way you can break them up to make 9. Now, sometimes I might just write these on the board, these dots on the board, and then draw circles around them or shapes around them with a whiteboard marker to show how they can be divided into different parts to make 15. You can hand them out on the table and they can break them up. But the idea is you have this kind of shape and then learners break them up to see that there are only certain combinations of those numbers that actually equal 15. So we come back to our magic square here, and maybe we want to explore number 1. So we want to see where number 1 would fit in this magic square. So number 1 is involved in making 15 when we go 1 plus 5 plus 9 equals 15. That equals 15, that's great. 1 can also be involved when we go 1 plus 6 plus 8, that's 15. The next one is 1 plus 7 plus 7. Oh, that's a double. We can't use that one. So those two are actually the only ways that you can make 15 with 3 digits using 1. So there's only 2 ways you can use 1. So 1 equals 2, right? So 1 has to go on the side, that means, because it's only involved twice. What about 5? Well, you could go 5 plus 1 plus 9 is 15. You could go 5 plus 2 plus 8. And if you just notice, these numbers here are going up in value, and the numbers on the other side are going down. It's a good strategy to do it. So 5 plus 1 plus 9 is 15. 5 plus 2 plus 8 is 15. 5 plus 3 plus 7 is 15. And 5 plus 4 plus 6 is 15. So that means you can use 5 with those numbers to get 15 4 different ways. So that means 5 must go in the middle, because remember, it's involved in 4 different equations. Let's have a look at another one. What about a 9? Where's our 9 going to go? Well, 9 plus 1 plus 5 is 15. 9 plus 2 plus 4 is 15. And 9 plus 3 plus 3. Oh, hold on. That's a double. We can't use that. So 9 is only involved in 2 ways to make 15, just like the 1. So 9 has to go on the side as well. Let's do one more. What about 2? How many times is 2 involved in making 15? 2 plus 4 is 6, plus 9 is 15, so there's 1. 2 plus 5 plus 8, 15. 2 plus 6 plus 7 is 15, and that's it. So 2 can be used in 3 equations, and therefore 2 has to go on a corner, because remember, our corners are involved in 3 different equations: straight across, up and down, and diagonally as well. So we found these numbers that fit, and now you can, if you wanted to with your learners, just do some arithmetic here. 2 and 9 is 11, so what's going to have to go there? A 4. Now we've got 4, 5, and something along the diagonal. So we're just trying to plug in the gaps at this point, and we can work out what each one is and complete the magic square. So that's how the magic square can be used to develop mathematical thinking, taking the learners through that process, and also using the principle of breaking up simple numbers into smaller component parts. Now, I'm well aware that that is a lot to take in as you watch that, and you might want to sit down and work through that by yourself before you do it with the class, but it's a great way to work with learners. Now, if you could finish there, or you could actually use another sort of reinforcing activity. A lot of my learners really like to, or have liked to gamble, and so I am constantly showing the follies of gambling within my numeracy lessons. And so I might ask them on a different occasion, hey, which numbers are the easiest to roll with 2 dice? And often the learners have never really thought about this, what numbers pop up the most when you roll 2 dice. So I might ask them, hey, how many ways can you roll a 2, for example? Snake eyes, how many different ways? And it turns out there's only one way to roll a 2 with 2 dice, because you have to get a 1 and a 1. And so it's like, okay, so your odds of rolling a snake eyes are actually pretty slim. So then I might ask them, how many different ways can you roll a 7? And I would let them work this out, and you can roll a 7, with a 1 and a 6. You can roll a 2 and a 5. You can roll a 3 and a 4. And that's it. So there are 3 ways to roll a 7. So there's 3 times as much chance of rolling a 7 as there is rolling a 2, which is interesting. And then you might do that activity with a 12. What are the ways you can roll a 12? And that would be, a 6 and a 6, so it's just 1. And so on with all the other numbers that you're working through. And by now those learners should be beginning to get the connections between what we're doing here. So it's better to bet on a 7 being rolled than a 2. And here's a game I have used in the past. Everybody picks a number from 2 to 12, and the idea is that you, the tutor, pick the 7. And then you roll it 20 times, and whoever's number comes up, they get a point. So if a learner has picked number 8, they get a point every time an 8 is rolled, or so on. And you begin to realize pretty quickly that the 7 is most likely to be rolled, more than an 8, more than 9, and so on. And so it's a good game to play, although, to be honest, it's never worked out that well for me. Sometimes the odds are just against you, and the people who pick a 3 or a 4 win. But that's part of understanding the statistics and how that works. So there are 3 quick activities for you. The paper activity, where you cover the counters, one part of the counters, and get them to work out what are missing, and you want them to transition there from counting on their fingers to beginning to do it in their head and be able to break up numbers. And then we looked at using counters and working out how a number of counters, for example 5, can be broken up into 2 different groups, 1 and 4, 3 and 2, and so on. And then progressing that into exploring it for 3 ways, then the magic square, and teaching a real process for solving the magic square, and then bringing those skills over to dice as well. So hope you enjoyed this. This was just a quick intro into some of the work we've been working on lately, and I hope you found it enjoyable. Goodbye.